Hey everyone, welcome to my video on the center of mass, looking at 1D point mass systems. So the first thing you should have out is the balance beam with 15 washers. So if you don't have that out, go ahead and take that out, pause the video. So the first thing we're going to be talking about is this idea of moments. So before we can talk about center of mass, we have to talk about moments. So the moment of a point mass, about a fulcrum point, is the distance of the point from the fulcrum times the mass or weight at the point. So that's the definition. The main thing there to remember is that the moment of, say, a point, we'll just call it point 1, is the mass of that point times the distance from the fulcrum. All right. So the fulcrum is right here. So this is what we are calling the fulcrum. It's kind of this center point where I'm going to be tipping around that or trying to balance on that point. So this is what we call the fulcrum right there. And what we'll do is measure that distance from the fulcrum to, say, some point that we have a mass at. So this stack of washers would be my mass, and that distance right there, we just measure that out for that point. We'd also measure the mass or the weight at that point, and so in this case, I'm going to be using units of washers. It could be, you want to use kilograms or pounds or newtons or something like that, but what we're going to use is just units of washers for these guys. So this is 1, 2, 3, 4 washers right there. So we would say mass is 4. The distance, 1, 2, 3, it's like 4. I think this may actually be 3 right there, so I'm going to change that. So 3 washers at that point, and it's 4. So go ahead and multiply those. 3 times 4, that would be 12. That would be my moment for that point around this fulcrum here at 0. And then I can do that again for this one. So what I've done below in this chart is kind of give you an idea of one scenario where things are going to balance. So if I have a mass of 2 washers at a distance -6, so that's right over here. So we're thinking this whole distance across here is going to be, since I'm going left, -6. And I get a mass of 2, this will result in this moment of -12. So again, this multiplied mass times distance, that's my moment. This one we already done, so mass of 3, distance 4, so that's going to be moment of 12. And those two together will balance for this guy. And what I'd like you to do is kind of test out with your physical beams, write in a couple more scenarios where you think things may balance. You can go ahead and pause the video, but go ahead and maybe just write in balance scenario 2, B2, and maybe try to find another way that this happens. If you want to get really adventurous, you could try to come up with 3 stacks instead of just 2 stacks, but you can start with 2 and then maybe work your way up to 3. I mean, one way they're going to balance is if you just put stuff super even on both sides, so like a stack of 4 at a distance 3 and another stack of 4 at a distance 3 on the other side, but that's not super interesting. I mean, we kind of expect if it's symmetrical, it's going to balance. So try to come up with some things that are not symmetrical, kind of like this first one where you got different masses at different distances for these guys. So go ahead and pause the video, see if you can come up with a few of those, and then answer this question 3. Do you notice any patterns that might be happening? All right, well, you should have filled in this chart a little bit for a couple of these, and then we'll go and see what sort of observations you should have made. So I'm going to go ahead and fill this in real quick. All right, so here's one scenario that you probably didn't come up with, but you certainly could have. So I got a mass of 4 at a distance 5, so that would be on the right side over here. You have a mass of 3 at a distance -6, so you get an extra washer right there. And then you also have one at a distance -2, so you'd have one right here. And if you calculate the moments, mass times distance, so you have 4 times 5 is 20, 3 times -6, -18, 1 times -2 is -2. And all of that should balance out because I have a total moment of 0 for that system. So if I add up all the moments together, I should get a total moment of 0 for the system when all the individual moments have been added up. So that is the main observation that you should make on this guy, is that for the first scenario, right, -12 and 12, that added up to 0. Same thing if I put more stacks, as long as the moments add up to 0, everything should balance out. All right, we'll go ahead and go on to the next page. Take a look at this. So I'll let you guys try to work on this one, and if you got more questions or you're not sure about it, you can put them in the forum. This next one is going to be, after you finish that, finding the mass of the beam. So you may have different beam masses depending on which one you got. So the first thing you're going to do is kind of move the fulcrum over. So you should have a center dot kind of mark. So just move it over to 2. Line it up as best you can. And then put 6 washers at the end of the beam right there on the right. This should get you pretty close. So masses are likely between 16 to 18 washers, again just depending on which one you got. So so go ahead and start with a mass of 6 over here at a distance 6 from this new focal point. If the beam balances, fantastic, you're ready to just skip to step 5. If not, then you'll have to move one of these either left or maybe add an extra one. So if it's too heavy on the right, or that side of the beam is just way down on the right, then you'll want to take your top washer and start moving it over to the left. Figure out where it's going to balance. So that's sort of like this blue one, is we've taken this top washer and moved it over, so it's only 2 away instead of 6 away on that guy. If it's too light for some reason, say this end is still going down on the left, this side is up on the right, then you'll just need to take one more washer and start putting it at, maybe at 2 or at 4 until it balances. So so go ahead and try that until you get yours to balance out. Once you've done that, step 5 is computing the moment. So let's measure from the fulcrum right here and see what we get. So this would be from that fulcrum a distance 6 right here. This is 6, and our moment on the right, say MR, is going to be 6 times 6, which is 36. This center point is where we can think of all our masses being concentrated here on the left, and so that would be a distance -2, and we don't know the mass, so we're just going to say this moment on the left is whatever that mass is times -2. And what we saw before is these two should add up to 0, which means they should be equal except for the negative. So we would get something like this mass times -2. And actually we can say plus 36 instead of writing that out again. Those masses should add up to 0. So move the 36 over, divide by -2, I should get 18 as my mass of this beam. And you can do the same thing for this one. The total moment's going to be a little bit less for this one because I got a stack of 5 here and a stack of 1 here. So you're basically just computing the moment on the right side, and then because you're a distance 2 away, you'll just be dividing that by 2 to get your mass. So that's kind of the step 6 right there. Record the mass of your beam. All right, so we're using units of washers. So the mass of my beam is, so if I had the yellow one, I put 18. I think the blue one comes out to 16 on that. But whatever it is, just fill that in. So it could be something like 18, could be 16, maybe 17. So just record whatever that's going to be for you right there. All right, and that will get used in the next task. All right, so a few definitions that we're going to need for these guys. So if I have just a general system of point masses, then the moment of the system, we already kind of talked about that, is going to be adding up all the individual moments. So all the individual mass times distances, we'll just add those up. So we got that summation notation right there. Total mass, again, just adding up all the masses, not taking in distance into account. So again, the sum of just all your individual masses. And then you can actually compute the center of mass just by taking that total moment of the system over the total mass of the system. So we'll be trying that with these guys. So what you want to do is kind of redo your beam, take the fulcrum off, and put the weights according to this. So right here at a distance -8, I got 4. At a distance -5, I have 2. Over here on the right, at a distance 5, I have 2, and a distance 7, I have 1. And the center, the mass of my bar, is whatever you just found on that last step. So I might say this is, if I had that yellow one, I might say it's 18 or 16 or whatever it would be. Right. Whatever you found on the last page. And then go ahead and compute this out. So you'll just be doing mass times distance for these guys. So I'll go ahead and do this one scenario here. Put those values in real quick. Go ahead and try it. Pause the video. See what you get for yours. Check it. I'll go ahead and kind of pause it and then just write everything in here. So pause the video. Try to compute it out. See what you get. All right, so I should have got something like this. Moment is -25. Notice the mass of your beam gets multiplied by a distance 0. So that won't really have an effect on the moment, but it will on the total mass. So I used a mass of 18, so I'm getting 27 here. If yours is 16, you would have got 25. So it just kind of depends on your own beam. And then your D bar, this distance of the center of mass from the center, is going to be just that moment over the total mass. So -25 or 27 in my case, which is about -0.926. So I would go just a little, not quite to -1, but just a little short of -1. That's where I would want to center my fulcrum to check and make sure that this thing balances right there. So you can do that with your own beam. Also try number 2, see what you get. You should be able to check to make sure that it actually balances with the beam just by placing the fulcrum at the place that you computed for this guy. On the last page, there's one more here, and again, I'll let you try that. You can post questions to the forum if you need to about this one, but just find a way to balance the bar where D is 2. So this should be your center of mass at the end. Try to find a way that's going to happen, and you can kind of think about where you might want to put some masses on the left and the right, so that moment comes out to equivalent on both sides of this value of 2. All right, and then some practice problems right here. So you can go through those practice problems. There are some answers here at the end that you can check afterwards, but go ahead and try those for your homework. Again, any questions you can put in the forums, and that's it. So that'll do it for center of mass, point masses, 1 dimension.